Hey everyone, Karnika here, and buckle up because we are about to dive into an incredible journey through the world of machine learning. Notice how your inbox is always neatly sorted, or why Netflix seems to read your mind with those spot-on recommendations. That's machine learning at work. But how did this all start? Curious? Let's hit rewind and explore the fascinating history of the powerful concepts behind machine learning. 1950s, the era of poodle schools and Elvis. Enter Arthur Samuel, a tech pioneer with a wild idea. Teach computer how to play checkers. Not exactly rocket science, right? Well, back then, it was. This was the stone age of machine learning. Like teaching a caveman to use smartphone. Then came the perceptron in the 60s, the first neural network, basically a machine learning equivalent of a disco ball. Flashy, promising, but ultimately limited. Think of it as a robot trying to do the robo dance but tripping over its wires. This led to the AI winter of the 70s, where the funding dried up faster than a puddle in the Saharas. But fear not, the 80s brought backpropagation. The hero who taught computers to learn from their mistakes, like a therapist for robots. It helped them figure out what went wrong and improve their game. Machine learning finally started walking, a bit with a toddler's wobble. The 90s saw the rise of support vector machine and decision trees. Basically the cool kids of machine learning. They were more powerful, flexible, and could handle more complex problems, like sorting your sock drawer without getting existential about mismatched pair. Now imagine a robot, teenager, confidently navigating a messy room, socks and all. Then came the 2000s, the deep learning explosion. Think of it as the machine learning equivalent of a teenager discovering social media. Suddenly, everything was connected. Information was flowing freely and things got really interesting. Enter AlexNet, a deep learning model that crushed the image recognition game. This was like robot finally graduating and getting that high-paying job. A big win for the whole AI community. Today, machine learning is everywhere, from composing music to writing poetry. It's like the ultimate upgrade. Now, the core concept that was promised. Classification and regression. First, classification. The email organizer. Imagine your inbox overflowing with email. Classification algorithm in machine learning are like superpowered assistant, meticulously sorting them into folders like important, spam, promotion. Think of them as ultimate declutterers. Except instead of throwing away old clothes, they banish spam and unwanted email with laser-like precision. Unless, of course, they accidentally send your vacation photos to the spam folder. But hey, even superheroes have their day offs, right? We'll study the details of this in further videos. Binary classification. That's like decoding if something is definitely pizza or definitely not pizza. Easy stuff. But then you get into multi-class classification, which is like sorting your socks drawer. This is gym socks. This is dress socks. This is an existential crisis socks. Now, how do we measure the success of these email organizers? We use fancy terms like precision, recall, which basically means how good they are at catching the bad guys, spam, and not accidentally throwing the good guys in the spam folder. And then there is F1 score, which isn't the new action movie, but sounds pretty cool, right? Next, regression, the house price detective. Ever wonder how real estate agents estimate house prices? Regression steps in as the ultimate price detective, solving the mystery of what's this house worth? Imagine it as a line or a curve that predicts the price on the clues like size, location, even the number of bathrooms. Now, there are different types of regression, just like there are different types of detective styles. We'll study the details of this in future videos. Linear regression. For now, linear regression is straightforward one, drawing a straight line through the data like by the book detective. And then you have polynomial regression, which is like the eccentric detective who uses unconventional methods. And let's not forget about the decision tree regression, where the detective follows a branching path of questions to reach the answer. But how do we know that our detective did a good job? We use metrics like mean square error, which sounds something like you'd yell at a computer game character for making a mistake. Then there is root mean square error, which means mean square errors cooler, edgier cousin. And finally, we have R squared, which tells us how much of the price mystery the detective solved. These algorithms aren't just for organizing your inbox or guessing house prices. They are revolutionizing fields like healthcare, finance, and even entertainment. Imagine doctor using machine learning to detect a disease earlier, or finance advisor predicting market trends. Hopefully more accurate than your Uncle Bob at Thanksgiving. So this is the whirlwind tour of fascinating world of machine learning. From its humble beginning to its groundbreaking application. It's clear that the technology is changing the way we live, work, or even think. Thanks for joining me, and I'll see you in the next video.